Okay, this is concept number 10, so it's the last one of the quarter, and it's probability. Now, probability is just, the actual definition of it is the likelihood of something happening. So you're trying to figure out what are the chances that this is going to happen. So the actual formula that we use for probability is the number of ways an event can happen. So all of the different possibilities. How many different ways could this event happen? Divided by the total possible number of any kind of outcome. Okay, so it's your actual ways of it happening over the total possibilities. So we want to know what is the probability of flipping a coin and getting tails. So I'm taking a coin and I'm flipping it. I want to know what is my probability of when I do that flip of it landing on tails. So there are two possible outcomes. Okay. So that's our total number of outcomes. One of those is what we're looking for, getting tails. So I have 1 over 2, 1/2. What is the probability of rolling a 6-sided die and getting a 2? Well, on a 6-sided die, there's only 1, 2. So I have one chance of this happening out of 6 total possible outcomes. It's a 6-sided die, so I have 6 different values that it could land on. One of them is the 2 that I want. So my probability is 1/6. Okay, so those are single probabilities when it's just a single event that you're looking for to happen. So now, next example. You're going to flip a coin twice this time. So I'm going to have 2 separate probabilities that are happening. But I want to know what is the probability of the coin landing on tails the first time and heads the second time. So I have 2 probabilities, but I'm going to calculate them together because I want these events to happen together. So I figure out each of their probabilities separately. Probability of getting the tails on the first flip. I have a 1 out of 2 chance. Okay, when I flip a coin, there's 2 possibilities for the outcome. There's 1 chance of me getting what I want, which is tails. Then probability of getting heads in the second flip. Again, I have a 1 out of 2 chance. Now, because I want these to happen at the same time, I want to land on tails the first time and heads the second time. Because of the word and, you have to multiply these 2 probabilities together. So I have 1/2 times the 1/2. Now remember, when you multiply fractions, all you have to do is multiply straight across. So 1 times 1 is 1, 2 times 2 is 4. So my final answer is 1/4. Okay? If it says and, you are multiplying. So now second example, you roll a 6-sided die twice. What is the probability of you rolling a 3 and then an even number? So our first probability is rolling a 3. Out of the 6-sided die, I have 1 3 on there. So it's a 1 out of 6 chance. Probability of rolling an even number. Now remember, your even numbers are 2, 4, and 6. So I have 3 possibilities that would make this happen out of my 6 total, which does reduce to 1/2. So you do need to always reduce your probability if you can. So now, because I want these 2 events to happen at the same time, and it says and, I'm going to multiply. So I take my first probability of 1/6 times my second probability of 1/2. Again, when you're multiplying fractions, you multiply straight across. So 1 times 1 is 1. 6 times 2 is 12. So our final answer is 1/12. Okay, you have to remember that if your probability says and, that you are multiplying. Now, second option is if we're looking at the word or. Okay? If we're finding the probability of multiple events and it has or between them, you are adding the 2 fractions. So we're going to roll a 6-sided die. What is the probability of you rolling a 3 or a 1? We still have to find the probability of these events separately. So the probability of rolling a 3, I have a 1 out of 6 chance. Probability of rolling a 1, again, I have a 1 out of 6 chance. So now I am adding these probabilities together because it said or. So I'm taking both of the events separately and adding them together. Now, when you add fractions, you have to make sure you have a common denominator. So in this case, the denominator of both of my fractions that I'm adding is the same. Because of that, I can simply add my numerators and leave the denominator exactly the same as what it was. So 1 plus 1 gives me 2. My original denominator was a 6, so my final denominator is a 6. Now, 2/6 does reduce. With probability, if you're able to reduce the fractions, you need to reduce. So our final answer is 1/3. Another example, a standard deck of cards has 52 cards and has 4 suits. Okay, so we have hearts, diamonds, spades, and clubs that make up those 52 cards. Each suit has 13 cards in it. So I have 13 hearts, 13 diamonds, 13 spades, and 13 clubs. That'll give me a total of 52 cards. What is the probability of reaching into the deck of cards and pulling out a 2? So in that deck of cards, there are 4 2s. Okay? There's a 2 of hearts, 2 of diamonds, a 2 of spades, and a 2 of clubs. So there are 4 different possibilities for bringing out a 2 out of my total 52 chances. So 4 out of 52 reduces to be 1 out of 13. So again, you have to reduce your fractions if you're able to. Then the second one says, what is the probability of finding a red queen? Now, with a deck of cards, there are 2 red queens. Okay, remember there's 4 queen cards. 2 of them are red, 2 of them are black. So I have 2 red queens. So I have 2 possibilities out of my total possibilities of 52. 2 of 52 reduces to 1 out of 26. Third example here says a 3 or a jack. So I have 2 separate probabilities, 2 events that I'm taking place with the word or in between. So because it has or, I am adding these 2 probabilities together. So there are 4 3s. I have 4 out of 52. There are also 4 jacks. So I have 4 out of 52 of those. 4 out of 52 plus 4 out of 52 gives me 8 out of 52. That again reduces to be 2 out of 13. Okay, so because it's or, I'm adding these 2 probabilities together, which gives me 8 out of 52 and then reduces. All right, another couple examples. So now you have a bag of marbles. It tells you that 5 of the marbles are green, 6 are blue, and 3 are red. Now, what I don't know about this bag of marbles that it doesn't tell me is the total that are in there. But you can figure that out. If you have 5 green, 6 blue, and 3 red, add those together. 5 plus 6 plus 3 gives you 14 total. So you know there are 14 total marbles. 5 are green, 6 are blue, 3 are red. So part A says, what is the probability of reaching into the bag and pulling out a blue marble? So your chances of pulling out a blue, well, there are 6 blue. So I have 6 possibilities out of my 14 total. So 6 possibilities out of my 14 total reduces to be a 3/7. Part B says you reach into the bag and pull out 2 marbles. What is the probability of pulling out a red marble and then a green marble? Now, it does say and, so you have to remember to multiply these 2 together. I have 2 different events happening. I have pulling out a red marble and then a green marble. Now, the red marble that I pull out first, there were 3 red marbles out of, again, my 14 possibilities. So my red is 3 out of 14. Be careful when you get to the green. Okay? There were 5 green marbles in that bag. But remember, you had just taken out your first marble. So there are now no longer 14 marbles in your bag. You took 1 out, so now there's 13. Okay, so be very careful with these. There is now 13 in that bag instead of 14 because you took 1 out. So this probability is 5 out of 13 possible outcomes. Now, because this was an and probability, we are multiplying these two fractions together. Remember, with multiplication and fractions, you just multiply straight across. 3 times 5 is 15. 14 times 13 is 182. This doesn't reduce, so your final answer is 15 over 182. It's an ugly looking fraction. That's fine. Okay? Not all of these probabilities and fractions are going to work out nicely. Okay, another example. What is the probability of either pulling out a blue or green? So again, or means we're adding the fractions. So I'm going to first find the probability of a blue, which is 6 out of 14. Probability of green, there was 5 out of my 14, so I'm going to add them together. Again, they have the same denominator, so I can just add my numerator and keep the denominator. 6 plus 5 is 11. My denominator stays a 14. So my fraction, my probability is 11/14. Okay, now last type of probability that we have is you could have a problem with a spinner of some sort that has colors on it. It could have letters on it. It could have numbers on it. It could have a lot of different information. But it's the same setup. What is the probability of the spinner landing on a blue section? So remember, it's your possible, your event outcomes over your possible. So if I'm looking for blue, well, I have 3 possibilities for blue. Okay, so it's 3 out of your total possibilities. Well, this spinner is split into 12 sections. So you have a 3 out of 12 chance to land on blue, which then reduces to be a 1/4 chance. What is the probability of the spinner landing on a green or a yellow section? So because it says or, you are adding these probabilities together. Again, you still have 12 possibilities. If it's a green section, you have 3 of them. Yellow section, there's only 1. So you have a total of 4 possibilities out of your 12, which reduces to give you 1/3. Now, last example here, you are spinning twice. So we want to know the probability that the spinner lands on blue the first time and then red the second time. So I have, for my blue probability, I have 3 blue sections out of my 12. That reduces to give us the 1/4. Red section, I have 5 total red sections that it could land on out of my 12. Now again, because it said and, I'm taking those 2 probabilities and I am multiplying them together. Again, multiply straight across. 1 times 5 is 5. 4 times 12 is 48. Does not reduce, so you just leave your answer as 5 over 48. That's it for probability. So it's concept number 10, which is probability, the last one for quarter 4.